So we have our next speaker with us. Her name is Dr. Jasmine Jahan Tithi. Dr. Jasmine Jahan Tithi is a researcher focusing on high performance computing and software hardware code design of next generation processors, targeting large scale machine learning and graph applications at Intel. She received her PhD from Stony Brook University and worked as an intern in Google, Intel, and PNNL during her PhD after finishing her Bachelor in Computer Science and Engineering from the top engineering school of Bangladesh, which is named as BUET. By the way, she's from my alma mater, so I'm super proud to be hosting her here. Jasmine has been actively involved in Women in High Performance Computing and STEM workshops and taught girls about HPC in the WISC, I think Women in Science and Computing courses or something like that, at SUNY SB. Jasmine is also an associate faculty of the University of Goethe, Germany, where she is working on the Z inspection, a practical auditing process for trustworthy ethical AI. Jasmine is also a member of the ACM Future of Computing Academy, ACM Selects, and ACM Code of Professional Ethics Board. I'm proud of myself for going through this entire bio. You have some amazing achievements in your bio, Jasmine. The floor is all yours. You can go ahead whenever you want to.
Thank you, Farzana, for this intro. And I'm really happy to be here and also proud to be introduced by uh, co-alumni from BUET. So let's get started. Can you see my full screen? Okay, thank you. So hello, everyone. I'm going to talk about Zen inspection, a process to assess trustworthy AI. But I'll start with a story. As Farzana said, my day job is I'm a research scientist at Intel, um, working on high performance computing and parallel algorithms. So you might ask, how am I giving talk on trustworthy AI? So it all started from my own interest. I got an opportunity to organize a workshop on AI ethics at Heidelberg Nobel Laureate Forum in 2019. And from that, I got associated with University of Goethe in Germany, and there I started working on science fiction. So the first lesson that you want to take from my talk is that if you are interested in something that's not on your own expertise list, but you have time and you are passionate about it, go ahead, you should be able to do it. So artificial intelligence, or AI, is having an unprecedented impact in our everyday life. For example, it's being used for recommending products, services, entertainment, news, healthcare, loans, jobs, education, or even life partners. At the same time, there is a growing concern on ethical and societal implications of AI. And one of the questions that get often asked is, how do we know whether an AI is trustworthy or not? Even a more basic question is, what is the definition of trust? And the answer of trust depends on the use case, domain, and its context. We used the definition given by European Union high-level expert group, and according to them, an AI is trustworthy if it's lawful, respecting all applicable laws and regulations, if it's robust, both from technical and social perspective, and if it's ethical, respecting all ethical principles and values. They use 4 ethical principles rooted on the fundamental human rights, and these are respect for human autonomy, prevention of harm, fairness, and explicability. And they also suggested 7 requirements of trustworthy AI, and these are human agency and oversight, which includes respect for fundamental human rights and requires that human to be in the control. The second requirement is technical robustness and safety. It includes resilience to attack and security, fallback plan and general safety, accuracy, reliability, and reproducibility. The third requirement of trustworthy AI is privacy and data governance, and it includes respect for privacy, quality, and integrity of the data, and having fair access to the data. The fourth requirement is transparency, and it includes interpretability, traceability, explainability, and communication. The fifth requirement is diversity, non-discrimination, and fairness, and it includes avoidance of unfair bias, accessibility, universal design, and stakeholder participation. The sixth requirement is societal and environmental well-being, which includes sustainability and environmental well-being, friendliness, impact on the society and democracy as a whole. And the seventh requirement is accountability, which includes auditability, minimization of harm, and reporting of negative impact, trade-off, and opportunities for redress. So the next question that one might ask is, why do we need inspection process? Although self-assessment is encouraged and is always welcome, the problem with self-assessment is that it often has the problem of conflict of interest. A developer may not understand what are the problems with his system. Furthermore, evaluation of ethical impact is challenging because it involves evaluating impact not only on the individual who are using the system, but also on their friends, families, communities, society as a whole, and planet. And some ethical impact are only fully understood after deployment. Think about Facebook and its impact. Furthermore, claims of black box models are difficult to verify for those outside the organization. And therefore, Turing Out winner scientist Joshua Bengio and his colleagues suggested that a coalition of stakeholders should create a task force to research options for conducting and funding third-party auditing for AI systems. A same opinion was uh, suggested by European Commission and the Organization of Economic Cooperation and Development Forum, also known as OECD. And they suggested that we should develop auditing mechanism for AI systems to allow public enforcement authorities as well as independent third-party auditors to identify potentially illegal outcomes and harmful consequences of AI systems. And all these are motivations behind developing inspection process. Inspection is a practical assessment process for trustworthy AI based on applied ethics, and it can be applied to a variety of domains, including business, healthcare, public sectors, and many others. It is customizable based on use case, domains, and context, and it also allows to use existing frameworks, checklists, and tools as plugins. Inspection focuses on assessing technical robustness, legal and contractual implications, ethical and societal implications, and these are all really covered by the EU high-level expert group. Now note that illegal and unethical are not the same thing, and at the same time, legal and ethics depends on the context. So far, we have covered 3 use cases using inspection, and these are AI for predicting cardiovascular risk, machine learning as a supportive tool to recognize cardiac arrest at emergency calls, and the third one is deep learning based skin lesion classifier. So we used the policy of learning by doing, and our inspection process really evolved as we did our first use case, which is AI for predicting cardiovascular risk. This is our core team, and the team includes experts from computer science, machine learning, cardiologists, healthcare professionals, philosophers, lawyers, and we extended the team to cover the need for the second and third use case. It includes now dermatologists, philosophers, and judges, as well as diplomats. So our team now is really a multidisciplinary. I think my slides are, let me pause and make sure that my slides are not using timing. Okay, perfect. So our team now really is a multidisciplinary team. And I will tell you that this kind of multidisciplinary team is really needed for this kind of inspection process. So in simple terms, inspection is really an orchestration process to help experts to assess the ethical, technical, and legal implications of a given AI. It can be used before production to help relevant actors to be aware of ethical, social, technical, and legal risk and pitfalls. It can be used for auditing and performing an ethical evaluation over time of a deployed AI systems, which we call ethical maintenance. It also covers post-audit stage and can be used by third-party investigators outside the organization who are deploying the AI. The uniqueness of inspection is that it's practical. Unlike other policies and principles out there, and it can be used at different stages of the AI lifecycle. Here is the inspection process in a nutshell. We have setup phase, assess phase, and resolve phase, and I'm going to talk about each of those phases in the coming slides. So in the setup phase, we start by checking some preconditions. We decide we want to do the inspection or not by assessing conflict of interest. We need to make sure that no conflict of interest exists between the inspectors and the entity or organization to be examined. No conflict of interest exists between the inspectors and the vendor of the tools that we use for the inspection. And we also need to assess potential bias of the team of inspectors. It's a go if all three are satisfied positively. Um, it's a still go with restricted use of the tools if number two is not satisfied. And it's a no-go if either number one or number three is not satisfied. Next, we create a log or protocol that contains information over the life cycle of the inspection process, including information about the team of experts, the steps done in data preparation and analysis, and the use case evaluation of the tools, as well as any action performed as part of the investigation process. The protocol can be shared to the relevant stakeholders at any time to ensure transparency of the process, as well as possibility of redoing any actions if needed. Next, we define a catalog of questions to clarify the expectations of the stakeholders. For example, who requested the inspection, for whom the inspection is relevant, is it recommended or required by law? What are the sufficient and necessary conditions that need to be analyzed? And how to use the results of the inspection, whether it's for verification purpose or certification or sanctions. We also need to understand what to do with the assessment. Will the result be shared with public or kept private? And in the latter case, the question is why. This could be related to the definition of intellectual property of the AI involved. We need to clarify what is and how to handle IP of the AI and the entity involved, and identify possible restrictions to the inspection process and what are the possible consequences of that. We also need to define if and when code review is possible and needed. And we also need to make sure that there is no risk in the security of the system, privacy of the underlying data is ensured, and no undermining of intellectual property is happening. And we also need to define the implications if any of these are not satisfied. At this point, we might need to make a trade-off regarding whether we want to disclose all activities of the inspection versus delay them to a later stage or not disclosing them at all. The next step in the setup phase is to do team building. A team of multidisciplinary experts is formed, and the composition of the team is a dynamic process. Experts can be added at any time based on the need of the inspection, and note that the choice of expert has an ethical implication. Next, we define boundaries and context of the inspection. In other words, we define the ecosystem around the inspection process, and it includes sectors and parts of the society, level of the social organization involved, publics, which include actors, different stakeholders, as well as political and economical dimensions. We need to clarify what to investigate because AI is not a single element. It cannot be considered in isolation. AI is dependent on the domain where it is deployed. AI is also part of one or more digital ecosystem. It is part of different processes, products, and services, and it is also related to people and data. We also need to define time frame of the assessment. For example, one can assess only the present challenges, which are the risk imminent today, or near future challenges, which are risk in the near future, assuming current technology, or long run challenges, which are risk and challenges in the longer run as the technology become more stable and advanced. The choice of time frame has an impact on our definition of ethical maintenance. So that ends the setup phase. And we move on to the assess phase by analyzing socio-technical scenarios. So socio-technical scenarios are created and analyzed by the team of experts to describe the aim of the AI system, the actors and their expectation and interaction, the process where the AI system is used, and the technology and context involved. This one requires several iterations among the team of experts, and this end up doing a concept building. So notice that we have multiple experts from multiple disciplines. So we have cardiologists, computer scientists, and we do not understand some of the terms that other person use. Um, so therefore, we need to through this process, we basically learn each other's terms, jargons, and language, and learn how to communicate effectively with each other. So the next step is to identify ethical issues and tensions um, in the socio-technical scenarios. So an ethical issue and tension refers to different ways in which values can be in conflict. More specifically, it's tensions between pursuit of different values in technological applications rather than abstract tension between values themselves. So for example, accuracy versus fairness. An algorithm which is accurate on average might discriminate against a specific minority. A flag is an issue that needs further assessment, and it could be technical, legal, or ethical. Here is some list of tensions that arise in practical applications. This is not exhaustive list, but you will get some sense what the tension means. So there could be tension between accuracy versus fairness, accuracy versus explainability. A deep learning model might be more accurate, but it's not explainable. Quality of services versus privacy, personalization versus solidarity, and so on. Next, we describe, confirm, and classify if such ethical issues represent ethical tensions with the stakeholders as well as discussion with experts. This is done by selected number of members of the inspection team who has the required expertise in that domain and ethics. And the goal is to basically reach a consensus among the experts and agree on a common definition of ethical tensions that will be further investigated in the inspection process. Next, we review the applied ethical frameworks relevant to the domain. So for example, healthcare has its own ethical framework. Similarly, there are bioethics framework as well as financial ethics framework. So if the domain that we are working on has its own ethical framework, we have to consult that first. Then we ask the experts to classify the ethical issues discovered with respect to a predefined catalog of ethical tensions, and then further classify them um, as either true dilemma, dilemma in practice, or false dilemma, where true dilemma means a conflict between two or more values, duties, obligations, both of which an agent would ordinarily have reason to pursue, but he cannot. Dilemma in practice means tension exists, not inherently, but due to current technological capabilities and constraints. For example, we have less data or less compute power, and so on. False dilemma is situations where there exists a third set of options beyond having to choose between two important values. Next, we map these identified ethical issues, tensions, and flags to the requirements of Trustworthy AI using rubrics or template. We map these ethical issues and tensions to the 4 ethical categories and 7 requirements of Trustworthy AI given by EU. Just to remind you what those are, the 4 ethical principles were respect for human autonomy, prevention of harm, fairness, and explicability. By the way, explicability means accountability and understandability. The 7 requirements of Trustworthy AI given by EU high-level expert group are human agency and oversight, technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination and fairness, societal and environmental well-being, and accountability. We also asked the experts to assess if the ecosystem respects the values of Western European democracy and whether the AI would cause concentration of power. Now let's pause for an example. I'll use our first use case as a running example throughout the rest of the slides. The first case study that we had was an AI for predicting cardiovascular risk. This has been considered as a non-invasive class 1 AI medical device that uses machine learning to analyze sensor data, electrical signals of heart of patients to predict the risk of cardiovascular heart disease. The system transforms raw data into features that better represent the predictive task. Mapping from input features to output prediction happens through several neural networks, which are then combined using an ADA boost ensemble classifier. And the output of the network is basically an index between -1 to 1. And the way it represents to the doctors is basically either a green light or the red light. This is a scalar function that depends on the input measurement, classifying impaired myocardial perfusion. So here is a simplified view of the ML pipeline that is used. The first step is the measurement and data collection that includes data acquisition, data annotation with ground truth, and signal processing. The second step is feature extraction and selection. The third step is training of the ML classifier using the annotated example. And the fourth step is testing, where actions are taken for a new data based on model prediction, interpretation by an expert, and then discuss with the patient. Here, the expert could be a doctor or a nurse. Here is a simplified socio-technical scenario and the actors involved. So the AI device is used by a doctor on a patient. And here are the possible actions taken. The AI system predicts a green, which means patient is safe, he does not have any issue. Doctor agrees. No further action is taken and the patient does nothing. The AI systems predicts a green. The patient and or the doctor do not trust the prediction. Patient is asked to do further invasive test. The AI system predicts a red. Doctor agrees. Nevertheless, no further action is taken. Patient does nothing. So patient does not care about his health condition. The fourth possible action is the AI system predicts a red. Doctor agrees. Patient is asked to do further invasive test. And in a later stage, the company introduced a third color, yellow, to indicate a general non-specified cardiovascular health issue. So through this socio-technical scenario and concept building, we identified several ethical issues and mapped them to the requirement of trustworthy AI. And here is one example of that. The data used to optimize the machine learning predictive model is coming from 3 different hospitals, all located in the same geographical area. And there is no background information on difference of ethnicity of the patient. It was not available in the data. So thus, there is a risk that the ML prediction can be biased towards certain population segment that is more popular in that geographical area. In this case, the minority will be non-Caucasian people and the majority will be Caucasian people. So when we map it to the ethical pillars, it's fairness. It falls under fairness. And under the 7 requirements of trustworthy AI, it's under diversity, non-discrimination, and fairness. And under that, it's avoidance of unfair bias. The ethical tension here is between accuracy versus fairness. An algorithm, which means that an algorithm which is most accurate on average may systematically discriminate against specific minority, in this case, non-Caucasian people. And the kind of tension here is basically it's a practical dilemma, because if they have more balanced data, this problem might go away. So now let's get back to the assess phase. The next step in the assess phase is execute, which really means that we do verification. And here is a subset of things that we want to verify. For example, we want to verify fairness, purpose of the system, question the design of the AI system, hyperparameters, how the learning is done, source of learning, feature engineering, interpretability, production readiness, and dynamic model calibration if that's happening, and how the model is maintained. And then from the verification, we give feedback to the stakeholders. We create path to investigate subset or an entire ethical issues or flag. A path describes the dynamic of the inspection and it's different case by case. Part of the paths can be executed by different team members or subset of the team members with special expertise. By following paths, the inspection can be traced and reproduced using the protocol or log. A path can be composed of several steps and team members execute those steps. Execution is performed in a variety of ways. For example, you can hold workshops, interviews, checking and running questionnaires and checklists, applying software tools, for example, Fairness 360 or black box to white box model tool, and then also measuring different values that has been claimed by the AI system. Through the execution of the path, we create evidence base or develop evidence base. We try to understand the technological capabilities and limitations of the system and also understand the perspective of different members of the society or the stakeholders involved and impacted by the AI, and then build a stronger evidence base on the current usage and impacts of the AI. So at this point, let's pause for an example again. For the system, the AI system that I was referring to, we wanted to verify fairness. To verify fairness, the first step is to clarify what kind of algorithmic fairness is most important for the domain. And then we also need to identify the gaps between the concepts. For example, there are domain-specific fairness criteria. There are also machine learning-specific fairness criteria. And there could be context-relevant ethical values that we also need to respect. For healthcare, one possible approach is to use distributive justice, which comes from philosophy and social sciences. And fairness could be defined as equal outcomes, equal performance, or equal allocation, where equal outcome means assurance that protected group, in this case, protected group are non-Caucasian patients, have equal benefit in terms of patient outcomes from the deployment of the machine learning models. Equal performance refers to the assurance that the model is equally accurate for patients in the protected and non-protected group. And equal allocation, which is also known as demographic parity, ensures that resources are proportionately allocated to patients in the protected group. To verify these fairness criteria, we need to have access to the machine learning model. Now, we also need to map the domain-specific fairness criteria that we choose by talking to the stakeholder and consulting the ethical framework of the domain. We need to map those to the fairness criteria of machine learning. And in machine learning, there are even other different kind of fairness criteria. For example, it has statistical parity, demographic parity, which is same as equal allocation, equal coverage, no loss benefit, and so on. And then we also need to identify which criteria are incompatible, so we cannot achieve both in those cases. For example, equal positive and negative predictive value versus equalized odds, which is same as sensitivity, or true positive rate, equalized odds versus equal allocation, and equal allocation versus equal positive and negative prediction value. Which type of fairness is appropriate for a given application and what level of it is satisfactory? Answering that question requires not only machine learning expertise, but also clinical and ethical reasoning. So to verify fairness, we created a path. This path mainly analyzed accuracy, bias, fairness, discrimination. It also considered unfair, bias avoidance, accessibility, universal design, and stakeholder participation. And through the execution of the path, we created some evidence base, and I'm sharing a simplified version and a subset of it. For the data sets used by the AI for detecting cardiovascular risk, a correlation with age was identified. The analysis of the data used for training indicates that there are more positive cases in a certain age segments than others, and this is possibly the reason for a bias on the age. There is also a higher accuracy prediction found for male than female patients. The dataset is also biased in having more male than female positive cases, and this could be the reason. The size of the data set for training and testing is small, less than 1,000 patients, and it was not well balanced with respect to gender, age, and with unknown ethnicity. This may also increase the bias effects mentioned above. And sensitivity or true positive rate was lower than specificity or true negative rate, which means that the machine will always not detect positive cases of heart risk. So the feedback that we provided, again, a simplified and subset of it, um, are that the accuracy, sensitivity, and specificity deviate in part strongly from the published values um, that the authors of the AI developer had, and not sufficient medical evidence exists to support their claim that the device is accurate for all gender and ethnicity. This poses a risk of non accurate prediction when, sorry, give me a second. Um, I'm back. So this poses a risk of non-accurate prediction when using the device with patients of various ethnicities. So the device has been produced in Germany and it was being sold in Africa, and um, we fear that it can cause a problem. There is no clear explanation on how the model is being medically validated when changed, and how the accuracy of the performance of the updated model compares with the previous model that was not obvious in the system. So that ends the assess phase, and we move on to the result phase. In the result phase, we assign scores or levels to the system that we analyzed. For example, we could give a Zinspected stamp, but it's optional. And there are also some scoring methodology that's being developed. So in future, we can also assign score. It could be something like, giving an energy score on the fridge, but AI is complicated. It's not static as fridge. So we have to keep updating the score. Um, there is also uh, and then we address and resolve the tensions by discussing with the stakeholders. We give recommendations. There we also discuss the trade-off and help the stakeholder to make the trade-off decisions if they want. And at this point, if the AI is under deployment, ethical maintenance can start. So here's an example of a recommendation given. Um, and again, it's a simplified version. We suggested that an evaluation protocol should be established and clearly explained to the users. They should continuously evaluate the metrics with automated alert. They should consider a formal clinical trial design to assess patient outcomes and periodically collect feedbacks from the clinicians and the patients. Future importance for decision making should be given, which was missing. Um, and it should provide feedback to the doctor to explain the reason for the decision. Um, some possible unwanted side effect of this kind of an inspection process is that assessing ethics of an AI may end up resulting in an ethical inspection of the entire context in which AI is designed, and this could raise issues and resistance. So to conclude, Z-inspection is a practical and dynamic inspection process for Trustworthy AI, and it's customizable. The lesson learned from our experience of the first use case are numerous, and I'll share a philosopher view. One of our team member who's a philosopher have recently published an article based on his learning, and I really pretty much like what he shared. Um, so one of the learning is that we should start at the end, thinking about what is the human level goal of the AI system. It's not the technical goal, not the financial goal, not the legal goal, but rather the human level goal, like what the AI system is trying to accomplish in terms of human impact on human life. We need to assemble a harmonious team where the team member can talk to each other and communicate with each other, crossing the boundary of their own field. um, Evaluation happens in real world, not in classroom, which means that some of the ethical principle might not directly apply. We might need to bend some of the corners in practice. And it's highly recommended that we should get our hands on the equipment. We use the tool ourselves, put ourselves in the shoe of the users and test it out to understand better. um, we should work from multiple directions. So we have, cardiologists, we have ethicists, we have machine learning specialists. So we work from all these dimensions to understand the ethical implications of each of those sectors. Um, we need to decide the ethical principle first and stick with them. So when we started our work, there were already so many ethical principles out there, but we need to like stick with one and use that throughout the process. That helped us to finish the work. We need to look at tension, like which values are important to different stakeholders and what is being sacrificed. And then don't fear rubrics, because oftentimes we had these workshops where we were discussing and we kept discussing, but we could not finish our discussion. So having a rubric or template to list our assessment really helped us to finish the work at the end. And that's all. If you want to know more, you can go to this xeninspection.org website and learn about our work. If you want to contact me, I have my email address there, and feel free to contact me. That's all. Thank you for listening to the talk. I'd like to take questions if there is any. Um, is there any question? Can people still hear me? Okay, so let me check the questions in the Q&A and I'll try to answer. I see a question like this. I have been reading about the new revelations about bias in AI and machine learning with diverse faces, as well as how it's used in employment screening and law enforcement. How can we ensure that it is being used accurately with fairness in mind? Um, the answer to that question is the entity that are using those systems need to definitely assess the AI for fairness by testing on populations and make sure that based on the domain where it is being used, that they are ensuring fairness of that domain. So as an individual who is not an user, but where the AI is applied, I possibly have not enough way to understand whether it's fair or not. So the organization who are deploying the AI, they need to take the action, as well as if it's used in governmental services like for judgment, the government should put auditors to make sure that the AI is fair. Um, if you are external researcher, you can also try to test. And if you don't have access to the machine learning, it's difficult to really understand the fairness properly. Um, so the next question is, are there any financial assistance made for minority students who are interested in attending any boot camp or workshop related to this area? So there are free workshops, basically, as well as courses on this topic. Um, for example, the Zane inspection work at University of Gautam last summer and this summer, there are courses that are offered, which are open. You can just register and attend. I have been seeing posts from professors at different universities who are looking for students to work on this area. Um, and there are also a workshop by a standard committee on explainability, which are also free. So look for them, and you can attend those workshops without any charge. About financial assistance, definitely if you join a PhD program, you should get a financial assistance. And there are many workshops which are free, courses are free, so feel free to take them. Um, the third question is, how do we find a female mentor in this area? The answer would be, again, I see a lot of female professionals who are working in this field. You can just go ahead and look in zainspection.org website. You'll see a lot of female collaborators there. You can just email them that I'm interested to know more. There are also professors in different universities who are working on this field, like there are professor in Cambridge University and UCLA. Go ahead and feel free to email them. If you email probably 10 of them, at least one will respond
Dr.
positively.
Jahan?
Yes.
Yes, I was just curious because I know that you have a doctorate degree, and and a lot of the people that may be on in your audience are students that are yet um, earning their undergraduate degree. For to pursue a career in AI or machine learning, do you have to have a doctorate degree, or can you still be able to uh, do the work that you're doing with either an undergraduate or a master's level degree, post grad work?
Um, for ethical analysis or the work I'm doing, you don't really need a PhD degree, but definitely you need to learn those skills to be able to participate. For example, whether you could participate as um, a machine learning expert, so you can learn about machine learning and technical details, and then you can contribute in that respect. Or you can learn about philosophy or ethics, and there are now field emerging on ethics, especially in ethics in healthcare, ethics in AI. So if you learn those skills, you should be able to participate. You don't need a doctorate degree for that. So having a master's degree or even courses after your undergrad should be able to enable you to do this.
And the other question I have is, what languages are you working with when you're dealing with machine learning? Because there are so many different types of coding languages that are out there. What specifically do you see that we should focus on?
For this particular work, we take different machine learning tools to assess the trustworthiness, right? So, and it's really, you are right, there are different languages that are being used for these tools. For example, the first case study, they used MATLAB, and say for the second one, they are using Python. Uh, so these are the common languages that are being used. And as a technical person, you would need some way to. Oftentimes, when you assess an AI, it might be a black box to you. You don't have access to the source code um, of the tool. In that case, you have to do whatever you can by treating them as a black box. And there are tools that helps even to analyze black box model, and these are mostly Python tools, or tools based on Python. Um, but if you have access to the model, um, you might find out that they used MATLAB, and you have to probably learn or understand how to use MATLAB on that. But Python is mostly popular, and different frameworks on top of Python.
That's very interesting because I just got out of another workshop that was for data science, and that was with learning R, and there was a question on there about um, what was the difference between R and MATLAB, and here MATLAB is being used because it's basically for higher maths and probably calculating beyond the statistical aspect of analysis.
I mean, these languages are, there is really very blur, window between them. So you can, if you learn R, you should be able to very easily learn Python and vice versa. So yeah, don't think that if you learn R, you won't be able to work on Python and so on. You might just need to put little effort to capture the other one.
Some of the topics that we've had this week, and I'm just curious about your experience because you're very unique. I see that you're a woman of color, you're a minority, and it looks like, and I'm judging only because I see that in your image you have a hijab and you're wearing a head covering. So I'm curious to know what one of the things that was spoken at the conference has been a lot of the biases that women have faced. Have you encountered any biases in the machine learning environment or workspace, especially since you listed a whole host of people that you worked with, and they were from diplomats to other PhDs to specialists. And did you encounter any issues in terms of just for being who you are?
I would say yes, but I would also say that after working for a while, the environment gets folded so that it becomes more favorable to me. So I mean, I will say yes, I have encountered biases, but then after working consistently through and showing who I am as an individual, it really helped me. And I always found that I have supporting environment around me to navigate, say, a new environment. Um, I cannot hear you.
Oh, sorry. I was just about to say, I'm sorry. I wanted to ask I'm apologizing for asking a lot of questions because I guess other people aren't,
No,
and I just have a ton,
okay, go
and I'm
ahead.
going off of them off of the top of my head. I'm just curious, like for those of us who are in the AI universe, and I am just like jumping into there a little bit, just in machine learning, and but I was just curious, like I've been seeing in the news, or at least it's not been in the news, but it's been more on the social media page, like what's happening at Google. And you said you interned there. I mean, like what happened with Tinnet, and then now with I forgot the other lead AI woman who spoke up about what happened to her coworker and her firing. And then she spoke up about that. And then 14 days later, she herself was also let go. Can you speak to that? And what was the environment for you working at Google, and what are your thoughts on what happened to these two women in this AI verse, and especially in ethical AI, especially because your topic is on AI ethics?
Say I am not. When I was interning in a different team, and my co-workers were really friendly. I really had no issues there. About current environment, since I'm not working at Google right now, so I should not speak about it. Everyone has their own view on what panned out or what was really inside. It's uncomfortable to hear those newses, but I should not really say anything. I would only say that if I had an offer right now from Google, I would also think about that before accepting that offer. So that's only my personal opinion. Because I'm working at Intel, and Intel allows me to do this volunteer work on ethics in AI, which is not directly related to my core research, but I am getting to do the volunteer work there. So, and I love this.
No, thank you. I mean, I just find that the whole idea, the concept of ethics and coding seems for all the different meetups that I have been in, it's women who are spearheading it and women who are really putting the focus and spotlighting that this concept of ethics and coding and ethics and technology. And I find that fascinating and very interesting just overall. And thank you so much for presenting what it is that you do.
What one thing or one lesson learned or one opinion that I see from my co-worker or collaborators in this work is that we all care about human. We all care about what we do. We want to have a positive impact from our work. That's like a common theme that resonant among us. It's not just the work. It's like we want to have a positive impact. And that basically in Xenospiction, almost all of the people there are volunteer. Um, it's all from this sense of we want to make a difference. We want to like probably save life by making sure the healthcare AIs are ethical and trustworthy. So that's basically the common theme.
Thank you. I don't have any more questions.
Okay. Anyone else has any question? I think I have some other questions in the questionnaire. Let me see whether I can answer any of those. How can I get contact to the speaker? I have my email at the end, so feel free to email me. Will the information of the session be sent to the conference attendees? I don't know, but I think yes. Some of the sessions chair might be able to answer better. I'm interested in the topic, but I will be in another session. Can I obtain the information? I think slides are uploaded, so you should, and it's recorded, so you should be able to see it. How can I begin a career in AI? I believe I'm interested in AI. My major is information system technology and concentration in cybersecurity. Is there a traditional pathway to follow AI with my major? AI is now, touching almost every field that we traditionally used to teach and learn. Cybersecurity is also inside cybersecurity. You should be able to use AI inside cybersecurity to handle or detect anomaly more efficiently. So even if you're doing cybersecurity, inside cybersecurity, there will be you will get an opportunity to use AI to detect cyber attacks more efficiently than before. So yeah, if you are working on cybersecurity, look for those research where you should be able to use AI to prevent security breach. Yeah, I think that's all. If there is no other question, I think we can finish the talk.